Hello everyone, welcome back to the channel. I hope you guys are doing well. So we will see today's daily challenge on Leetcode and try to solve it together. So today's challenge is not that difficult. The coding portion is very easy. Only the thinking portion might be a little bit counterintuitive, but yeah, overall it is simple. So let's try to understand the problem at first. Smallest integer divisible by k. You are given a positive integer k only, and you need to find the length of the smallest positive integer n such that n is divisible by k and n contains only the digit 1. So return the length of n. If there is no such n, return -1. N may not fit in a 64-bit signed integer. So you will be given a k value, okay, and you see the k can be from 1 to 1e5. It is told in the question, okay. So till 1e5 it can go, and you need to find a number n which is divisible by k, okay. So n modulo k must be 0. And what is the criteria of n? It can be only either one of the numbers 1, 1, 1, 1, 1, 1, and so on. Okay, and it is also possible that there may be, let's say, 1,000 ones, 1,000 times. Okay, so definitely such a big number you cannot fit in a 64-bit integer. Okay, even in long you cannot fit it. So you need to find that how many ones are there in this digit, what is the length of this n. Okay, so you just need to return the length of this n. Okay, so uh, one thing is that if you see, mm, if you start n with 1, you are basically doing a linear transformation of n, something like n equals to 10 into n plus 1, and from that you are getting 11. You do the same type of transformation. Let's say let's call this transformation plus. Okay, so if you do the same transformation, you get 111. Again, if you do the same transformation, you get 4 ones. Okay, so that's how you do understand. And if you see, this is a linear transformation. Okay, okay, so now in modular arithmetic, if you perform a linear transformation, the remainder remains same. So what do I want to say by this statement is that, let's say you have a number 14. If you want to divide this number by 5, okay, so you want to divide by 5, you know, if you divide 14 by 5, the remainder which you will get is 4, right? So in modular arithmetic you write it in this way. So 14 is congruent to 4 mod 5. You write it in this way, okay. It's just a way of representation in modular arithmetic. So there are also properties of this modulo, is that if you do a linear operation on this side as well as this side, then there is no effect. Okay, so let's say what I want to say is that it is equivalent to saying that if you multiply, let's say, this 14 into 2 and this 4 into 2, it remains still valid. So it means that 28 will be congruent to 8 modulo 5, and it is nothing but, if you see, uh, 8 modulo 5 is nothing but 3, right? Because if you divide 8 by 5, it will be 3, and so 28 is nothing but 3 modulo 5. So that's how you do this modular arithmetic. And one thing you notice is that even if you divide 28 by 5, you get the same result as you divide 8 by 5. Okay, so if you, even if you divide the remainder, even if you forget the main number and are concerned only about the remainder, still your answer comes to be correct. Okay, so that's what, instead of plus 2, so the thing is that, let's say, this equation we take, this modular equation we take, and we perform any linear operation. Linear means, let's say, multiply by a and plus b. So 14 into a plus b will be equal to 4 into a plus b and mod 5. So basically you will get the same remainder if you divide 14, I mean, if you find the remainder of 14a plus b or 4a plus b, you get the same remainder. Okay, same remainder. This is what I want to say. So what if a is equal to 10 and b is equal to 1? We get our required transformation, right? then only we easily get our required transformation. So you see what you could have done. Basically you could start with 1 and keep performing this transformation 10 into 1 plus 1, and every time you just keep track of the remainder only. Instead of keeping track of the whole number, you can just keep track of the remainder. Now you know the remainder, till how much the remainder can go. It will always be less than or equal to k, right? Because the k is the thing which you are dividing by. So it will be less than or equal to k. So yeah, here as it is given that it will be less than or equal to 5. If it goes more than 5, you can just divide it, find the modulo 5 again. So similarly, what do you do? In a simple operation, you can just write this. Let's say length is 1, and let's say the number num, you can call it 1. Okay, what you can do with that number num is that you can do num equal to num into 10 plus 1, but whole modulo k. This is the thing which you can perform every time, and let's say you can keep a while loop for that, and you know that as this length will go up to k. Okay, so this length can go up to k, so the remainders start repeating only after k times. So while length is less than or equal to k, uh, and this thing also, the num, the number num is not equals to 0. Okay, you can just keep performing this and keep incrementing this length plus plus. At the end you can return your answer. Okay, so that is what the simple code portion which we will do, and I hope you did understand the solution. There is no need to overthink at all in this problem. It is a simple mathematics problem, I will say. So you can just start with length ln equal to 1, and the number num which starts with 1. Okay, and if you just see that if k is 1, return 1, right? You just do this for the first thing, and while len is less than or equal to k and num is not equals to 0, you can just keep performing num equals to num into 10 plus 1, and you perform the whole mod k, this whole mod k, and length will be plus plus. And yeah, if you see the length, so if it just keep incrementing the whole time, uh, then what will happen, if it never comes to this num equal to 0, then it will be only breaking out, right? So if it never comes, it means that len is equal to k. So if you find somewhere that len is equal to k, not equal to k, is greater than k, right? Till less than equal to, it will be looping this. So if this condition break, it means that len is greater than k. So if len is greater than k, you return minus 1, else you simply return what is your length. Okay, so yeah, that's all. If length is possible, you return length. Otherwise, if length is exceeding too much, then you return minus 1. It will simply mean that you cannot do anything with that number. Okay, so you need to return minus 1. So just try to run this. I hope it will work just fine. Yeah, and even if you try to submit this, I hope it should give a decent runtime. So yeah, it is giving a 29% beats only, but this same code gave me 100% beats too. So yeah, it varies a lot. You see, with the same exact code, I ran again and gave me 100% runtime as well as 98% memory. So yeah, that's all. That's all for this problem. I will meet you in the next day. Till then, thanks a lot.